In the last video, we went over the trigonometric ratios, and we learned how to define sine, cosine, tangent, cotangent, cosecant, and secant. In most cases, when you're asked to determine, let's say, sine 48, you're going to need to do this using a calculator. And that goes for if you're asked to determine sine 48, cosine 48, tan 48. When it comes to most angles, you're going to need to use your calculator to determine the sine function of that angle or the cosine function of that angle and so on. So usually the way that you would solve this would be to plug this into your calculator, press the sine button, put the value of your angle into the brackets, and it'll spit out an answer for you. But in this video, we're going to go over some special cases of some special angles where we don't actually need a calculator to solve those angles. And those angles are also going to form our special triangles. So let's take a closer look at those special triangles. So the first one is a right angle triangle where we have a 90-degree angle here, of course, but our two angles here are 45 degrees. So we have 45 degrees here and we have 45 degrees here. And if you add all of these up, you're going to get to 180. So this is the first special triangle that you're going to need to commit to memory. And here we have two thetas. We have both of our thetas being 45 degrees. And it turns out that with a triangle like this, when you work out the lengths of the sides, we're going to get 1, 1, and root 2. And we know that when we have a right angle triangle, the square of the hypotenuse has to equal the square of the other two sides. So we know that for a right angle triangle, a squared plus b squared, if these two sides are represented as side A, side B, and let's say this is side H for hypotenuse, so we know that a squared plus b squared has to equal to the hypotenuse squared. And we can confirm that this is correct because we have 1 squared for a, b is also 1, so 1 squared is equal to, let's set that equal to h squared and confirm that we get root 2. So 1 squared is just 1, 1 squared is again just 1, so that means that 2 has to be equal to h squared, which means that h is equal to the square root of 2. So this is just to confirm that these sides do follow the Pythagorean theorem. And now this is just one of the cases that you're going to have to commit to memory, and it's going to do you a lot of good to just memorize that. So this is your first special triangle, one where you have your right angle and your two interior angles are 45 degrees. We're going to have 1, 1, and root 2 as the side values. So now let's take a second to actually put these into our sine, cosine, and tangent functions. So if we were to take sine of 45, and either of these angles are 45, so you can choose either of these. So if we took sine of 45, we know that sine is opposite over hypotenuse, so the opposite side would be 1, and the hypotenuse would be square root 2. So sine 45 is going to be 1 over root 2. If we were to take cosine 45, cosine 45 is going to be adjacent over hypotenuse, so we're going to get 1 over square root of 2, because this is the adjacent side here. So we have 1 over square root 2 as well. And if we were to take tan of 45, we would get tan is opposite over adjacent. So we would get 1 over 1, which is just equal to 1. So for our first special triangle, we know that these are going to be the answers that we get when we take sine, cosine, and tangent of those angles. So if you're asked to determine sine 45, cosine 45, or tan 45, you're going to know right away what the answers are going to be without having to plug this into your calculator. So 45 degrees is the first special angle that forms this first special triangle. And remember, if you had to figure out, let's say, cosecant 45, or cotangent 45, or secant 45, you can easily calculate that by just doing the inverse of these respective functions. So cosecant we know is the inverse of the sine function, which means that cosecant 45 is going to be root 2, because if we flip this, we're going to get root 2 over 1. Cotangent, that's the inverse of the tangent function, we're still just going to get 1. And secant, which is the inverse of the cosine function, is again just going to give us root 2 if we flip this. So in each of our special angles that we're going to go over throughout this video, just keep in mind that if we are trying to actually figure out the inverse trigonometric functions of cosecant, cotangent, and secant, you can just figure that out by flipping what you got for sine, cosine, or tangent. Let's go over the next special triangle that you're going to come across. So the next special triangle, we're going to, of course, have our 90-degree angle here. But instead of having 45 and 45, we're going to have 60 degrees and 30 degrees. And again, if we add all of these up, we're going to see that we get 180. So this is the second special triangle that you're going to need to memorize. And while there are actually only two special triangles, the 45, 45, 91 and the 60, 30, 91, we're actually going to have three special angles for which we don't need a calculator to solve the sine, cosine, and tangent functions. And that's because when we're dealing with this triangle, because both of these interior angles are not the same, in the last triangle, both were 45, which meant that no matter which angle we chose, we would get the same result. But here, one angle is 60 and one angle is 30. So we're actually going to look at when we use this as our theta. So we're going to learn how to solve sine, cosine, and tangent of 60. And we're also going to learn how to solve sine, cosine, and tangent of the 30-degree angle if this was our theta. So let's start off with this 60 degrees. And I'm actually going to rewrite these in color so we know which we're referring to. So let's write this one down in red. That's our 60-degree angle. And then we have our 30-degree angle here. So with this special triangle, our 30, 60, 90 triangle, we're going to have the side opposite 30 is going to have a value of 1. The side opposite 60 has a value of square root 3, and the hypotenuse has a value of 2. So again, this is just something that you're going to have to memorize, and if you do, it's going to make life a lot easier for you. So the way that I just remember it is that one of our sides is 1 and one of our sides is root 3. And our 30 is opposite the 1. Our 60 is always going to be opposite the square root of 3. And if you can't remember that the hypotenuse is 2, again, you can just solve that by using Pythagorean Theorem. So we know that a squared plus b squared has to be equal to h squared, and a and b are our two sides, and h is our hypotenuse. So if we have square root of 3 squared, we have root 3 squared plus 1 squared is equal to h squared. And the square root of 3 squared is just going to be 3, and 1 squared is 1, and that's equal to h squared. So we know that 4 is equal to h squared, which means that h is equal to 2, because if we take the square root of both of these, we're going to isolate for h, and we get that that's equal to 2. So we can solve that just using Pythagorean Theorem. So now let's look at this theta here. If we're dealing with our 60-degree angle, let's try and find sine of 60. And we know that sine is the opposite side over the hypotenuse, so the opposite to this angle is going to be root 3. Our hypotenuse is 2. So sine of 60 is root 3 over 2. Now for cosine, if we're taking cosine of 60, cosine is the adjacent side over the hypotenuse. So this is our adjacent side, it's 1. And our hypotenuse is 2. So that is going to be 1/2. Now let's do tangent of 60. Tan 60 is going to be the opposite side over the adjacent side. So our opposite side is root 3. Our adjacent side is 1. So we're going to get root 3. Now let's say this is our theta. Now we're interested in this angle here, and this angle is a 30-degree angle. So if we're trying to find sine of 30, then we know that sine is opposite over hypotenuse. So our opposite to this angle is going to be this side here. So that's going to have a value of 1. And our hypotenuse here has a value of 2. So sine 30 is 1/2. Cosine 30 is going to be the adjacent side over hypotenuse. And this is our adjacent side to this angle here. So it's going to be the square root of 3 over the hypotenuse, which is 2. So cosine 30 is root 3 over 2. And tan 30, we know that tan is opposite over adjacent. So our opposite is 1, and our adjacent is root 3. So we're going to get 1 over root 3. So now we know 3 different angles for which we don't need a calculator to solve sine, cosine, tangent. And of course, we know that if we just flip these around to their inverse, we can also solve for cosecant, secant, and cotangent. So we know how to solve for 3 different angles, one that has a value of 45, one that has a value of 60, and one that has a value of 30. And when we see any of those 3 angles, we won't need a calculator to solve for sine, cosine, tangent, cosecant, cotangent, or secant of those. And you can easily just remember those by memorizing those 2 special triangles. And let me actually write down both of those triangles and each of the values associated with them, so you can just copy that down. So here we have our 2 special triangles. Our first triangle has 2 interior angles of 45 and a 90-degree angle, and the sides are 1, 1, and root 2. And here we have our 60, 30, 90 triangle, where we have one interior angle of 60, one interior angle of 30, and the other, which is 90, and the sides are 1, root 3, and 2. And if we just remember both of these triangles and remember what the side values are and what our interior angle values are, and if you remember what your trigonometric ratios are, which is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent, or SOHCAHTOA, then you can easily solve for sine, cosine, tangent of 45, 60, or 30 degrees without using a calculator.